tried, we are going to talk a bit about Pythagoras.
So I didn't get to finish eating my lunch. Can I eat my lunch?
You could always eat your lunch in your own. As long as you're with me, like focused and paying attention, you're good. You're probably going to want a ruler. You're probably going to want highlighters. Sorry if you don't know what the word clutch means. A clutch is the thing in your vehicle that allows you to change gears. It's very important. So when somebody says, oh, that's clutch, it's an expression that means that's important.
I thought that was
And when you'll gear change vehicle, you have to push the clutch in and change the gear, let the clutch out. I mean, you can have a single gear vehicle. Like, your revs would go really high, and it would be extremely inefficient. The higher the revs, the more inefficient it is. Alright, so, our paper's here. Sorry, our paper's here. Those, I should have stuck those away so you weren't even tempted. We are diving into angles and the Pythagorean Theorem. So, sorry I didn't copy it all over to my more fun and colorful. Yes, Simon?
So you said examples from class, see back of paper, but on the back of the paper, there's more homework.
Look at the bottom. It's not always examples from class, sometimes it's like a notes box.
Why are you putting it up?
Because I couldn't fit it on the front because the other images that were cut. Like the giant table of data. I mean, you asked real questions, I gave you real answers. I just was forced to put it on the back. It absolutely wasn't laziness. I worked very hard to try to fit it on the front, and then I couldn't, so I gave up. Because reality. So, hey, Audrey can hear lunch, but you guys both have to be paying attention as well. And for some reason, it seems like you're both facing in towards Audrey. And I get it, she's got food, but the math is up here. No, you're hungry for math. You're not hungry for food. You're hungry for math. So, as you've learned about through social studies, Pythagoras was. Who was to finish my Simon?
He was a Greek mathematician.
He was a Greek mathematician who's got more. Fair?
He made that perfect there, and he also did a lot of lines and friends.
Okay. What? Okay, we already talked about the cup thing. What about geometry? Okay, that doesn't really have to do with math, but that's very interesting. No. Audrey.
I saw in Accounting Academy they did that he made a club just for mathematicians.
He did. It was called the Pythagoreans. I mean, not to be conceited or anything, but I was named this club after myself. Henry?
The club was called the cult of Pythagoras.
It may have been. Like, are you making a joke or is that serious?
That's serious.
That is kind of scary.
He made the triangle numbers thingy.
The triangle numbers thingy. You are absolutely right, Patrick.
He made the Pythagorean Theorem.
But before he named it after himself, because, he was a very modest man, he called it the triangle number thingy. That was, Avi. So his legacy, if you will, is a formula that is, if you want to write it down, we will write it down many, many times, but it is a squared plus b squared equal to c squared when a and b are the legs or the perpendicular pieces of a right triangle and c is the hypotenuse. And literally, you can prove this with squares. So if you make a square with the edge length of the leg, and you make another square with the other length of the leg, you got an a square and a b square. And if you make a square off your hypotenuse, yes, it will be at a weird angle because it is diagonal. The amount of area in the c square will be equal to the a square and the b square put together. It's really cool. That always, always, always holds true. So if you want to run down where we're going this chapter, it's going to be a longer one because we only have 2 chapters left. They're pretty important and they're broken up into sections, so expect some mini masteries along the way. We won't make it all the way through chapter 9 before we have a mastery because that's a lot. So chapter 9.1 sets up information that we need to understand before we can understand how Pythagoras was able to do what he did. So while we're gonna get into the Pythagorean theorem, we're not gonna get there yet. We have to understand some relationships between lines and angles first. Hold on, I'm gonna get to you. Then in 9.2, we will actually go visit Pythagoras and talk about how this got built, and we'll probably actually prove it ourselves. And I don't know where it is, but I have a mug somewhere in here that says that I am better than Pythagoras because in my college class, we actually proved the Pythagorean theorem with any polygon, which is really fun. Alina.
Also, the equation only works for right triangles.
Correct. Right. So that's why they have to be perpendicular legs. Yep. Right triangle. Who remembers why hypotenuse is called hypotenuse? What does hypo mean? Simon? No. What does hypo mean? You should know this.
Hypo means the speed, right?
No. Hypo, like hypothermia. Hypo. Guys, if I open the wall right now, Miss Goldring's part will shatter. This is a stem we've already had. We had it?
No.
Then it's on list 3, so learn it now. So, hypotenuse is called hypotenuse because the right angle of the triangle, the hypotenuse is under the right angle. Hypo means under. Hypothermia, your body temperature is under. That's different. That's actually, that might still go with under. Like, it's under investigation. It's under, like, you know what I mean?
Under, like, behind the actual.
So, we got to be on topic. I'll take one more question. Henry?
What does hypo have to do with hyper?
Different stem, thank you. So, hyper means over, hypo means under. So they're like the opposite. What is what? It can mean a couple things, but that's because we've already spent enough class on it now. I only have a half hour left. I want to stop delving down to like what is and what if. Normally a thesis, like if you talk to Mr. Vilo about he's going to be writing a thesis, is like an assertion of something you studied and you found out and you believe and you have research on and you want to like present to people. So a thesis is kind of like findings. So related to that, a theorem is what happens after. And guys, these are kind of important words for you to know that nobody taught me this young. So I try to like respect you guys and know you're really, really smart. A conjecture is what somebody thinks is gonna be true and wants to test. So at some point, Pythagoras had this conjecture about these right triangles. And actually, guys, Pythagorean theorem gets used all the time by all kinds of people. One of the best applications of it is really, really simple. Is the thing I'm building square? Right? Because if I'm building a house, I can step back and look at it and be like, it looks square. But by the time I get up to the second or the third story, we're like, uh-oh. That wasn't square. So literally, and this is still a little bit off topic, but one of the ways that people use the Pythagorean theorem is in a really common right triangle called the 3, 4, 5 right triangle. If you square 3, you get 9. If you square 4, you get 16. If you square 5, you get the sum of those, right? 25. If you're building something and you want to check, is this corner actually 90 degrees? You measure out 3 feet, make a mark. Measure out 4 feet, make a mark, and measure the distance between them. If it's not 5 feet, you done goofed. And this is how people all the time are using the Pythagorean theorem in a really simple way. But it goes back to Pythagoras, like literally goes back to him. Apparently I'm doing too good of a job teaching because you're interested and you have questions, but I gotta take them. Okay?
It's I don't know why I remember this, but when you have two sides, like when you do the Pythagorean theorem, then you get a whole number. It's called a Pythagorean triple.
Mm-hmm.
I don't know why.
Do you know the next one?
Nope.
Beyond 3, 4, 5?
Oh yeah, I do. I had to do a project on those numbers.
What's the next one? 5.
5, 4, 3.
No. 5, 12, 13 was the next one.
A long time.
Right, Henry?
Is there any way you can check if something is square before you set it up?
I mean, if you get a T-square or something, you can like literally like use a different tool. Or there's different laser techniques for stuff. But a lot of times people just measure. Like literally they use that measurement technique. Simon?
Our other math teacher used to have a huge poster of all of a bunch of Pythagorean
Pythagorean triples.
Yeah, and he had like
Mhm.
Yeah, that was Simon requested that. I know you requested that. Never mind.
All right, we got to get back on topic because we're losing some people and we got a lot to cover. First thing we need to do is make sure that we all agree on some symbol notation. So there's really no notes to take unless you need to write this down because you're like, oh, really? That's what that means? So when we want to show parallel lines, we use arrows going the same direction, not on the ends of the line. These would not be showing parallel. Those show that line continues. These show that the lines are parallel. Now, if you had two other lines in the same set that you wanted to show were parallel a different direction, let's say we have the top line is parallel with the bottom line, right? But this right line is also parallel to that left line. We can't use two arrows again because we already did. So either we'd have to use like one arrow or some other symbol that we create, like an arrow and a line, or an arrow, like use some other symbol involving arrows, normally just more or less. So we would put one arrow there and one arrow there to show the left and right are parallel to each other and the top and bottom are parallel to each other. Likewise, when things meet and perfectly make a 90, which I think most of us already know these, that is called perpendicular, and we put a box in the corner. Now really, you're only putting the 90-degree angle that creates a square, and that's also like the tool I just mentioned to Henry, a T-square, or a framing square, or anything that uses the word square, normally isn't a square. Because it's really funny when like your dad or somebody tells you, okay, go get the square, and the thing you bring back looks like this. And you're like, hey dad, I got the square, but it's a triangle, so I think you might be like confused. This is all we care about, the square corner. And then this actually is a different measurement side. Like literally, the tool called a square is not a square, it's a triangle.
There's some T-squares over there.
Yeah, and then T-squares are actual T's. All right, now flip to the back of your paper.
Oh, yeah.
Flip to the back of your paper. Read that. Close your mouth for a minute. Read the part at the very bottom. Below the, is this a function? Below that, I got you. Read that section. Highlight or underline important words if you want.
Yeah, I did something like this on Khan Academy.
Love compound.
Wanted me to.
Can I help you, Nick? Then wait somewhere else. You're not in my class right now.
I remember Khan Academy.
I love doing Khan Academy this summer.
It wanted me to reenact that scene in Star Trek where Captain Kirk is stranded on a planet and never mind.
So, beyond that section, talking about complementary and supplementary angles, and here's what you might want to write down to help you remember this, and it's super duper lame. And I'm telling you now, I'm really cheesy, I make dad jokes. Complementary angles.
Bad feeling about this.
I have a great feeling about this.
I have an amazing feeling about this.
So complementary angles are any two angles that then create together a right angle, right? So Alex, I really like that sweatshirt. It's Atari. It's a great throwback. It's wonderful. I've been digging Bianca's new haircut. It's just like, I just really do like it. It makes you look older, though. It kind of freaks me out. Logan's sense of humor is just like better than I could have ever guessed a 7th grader would have.
Oh my gosh, she's being nice.
I thought I was funny.
9.1.1.
Yes! Yes!
Praise it.
Praise.
You'll never ever again mix up complementary and supplementary. To complement, what?
I noticed that before anyone else did.
Of course Henry noticed that before
I
anybody.
was
I saw it, but I didn't want to say anything. Are you really right? Mr. Hudson was having a good moment that I didn't want to ruin it, like I always do. Yes. He did it again. He did it again.
Is it A? Or what?
No, I said compliment.
No, that's right.
Yeah, that's E-M-E-N-T, right? That's an E. I know I write terribly, but that's an E. Is that correct?
C-O-M-P-L-E.
Oh, I know, but is that right?
Yeah.
Okay. Now, if one of you lovely young people decides that you'd like to go become a bodybuilder, right? You're probably going to start going to the gym a lot and like kind of hulk up. But one of the other things that bodybuilders do is they take supplements to do what? Why do you take supplements?
To get older, recover, and get more protein.
You take supplements to get bigger, right? Nice and muscly until your muscles are so big that your arms stick straight out here and you can't lower. You're ruining it. So once you take all those supplements, your arms are going to end up looking like this, even if your head is pointed any direction. So you take supplements.
This is even worse. This is like,
It's so good.
Look, I don't have something cheesy for supplement. All I have is it's bigger. So complementary is the right thing to do. It's the right angle pair. Supplement, I don't have a funny cheesy thing. But seriously, people take supplements to get bigger. It's not the 90-degree pair, it's the 180-degree pair. So if you would like to create some cheesy memory trick, you have my permission and my express, yeah, that'd be great. Makeup, not right now, because we've already spent way too much time off topic today. Supplements are the 180 pair. Make a note in your notes if you want to.
I have something else to say.
Yes.
Do not take supplements. They're unregulated by the FDA. They are not safe to eat. You can put anything in there and nobody will know
You
unless
can put like rat poop in it.
I-
You're like, take these rat poop supplements.
unless somebody gets hurt. They can't sue.
I've been taking one for 2 years and I'm not overly.
I got really scared when I was going to say I've been taking rat poop for a long time.
Actually, if your arm is that big, that probably means you're doing an oil injection.
Nah, man, it's just you're swole. I got swole.
It depends. No, you guys have the biggest biceps in the world. It's 27 inches around.
That's absurd.
That's called oil injection.
Okay. Can we move on? Are we going to be able to? Here's where you don't know this stuff yet. Okay? On topic or no? Well, yeah or yes? I gotta move on. Don't derail us again. Is it necessary?
No fair.
When you have parallel lines, you immediately create certain situations. So on your graph paper, please draw a couple parallel lines. Use your graph paper to help you. Then draw what we call a transversal, which is a line that crosses. A transversal is like that street going across the railroad tracks.
Oh, it's like an equal sign, but like
Because
a
railroad tracks are sweet. And trains are awesome.
slightly bigger non-equal sign.
Thank you very much, Bear, for explaining to us how to draw parallel lines.
No problem.
We would have all been lost without you.
Bear, I am just fine with this. Every day I wake up and I think, thank you, Bear, for explaining. I do not.
So those are the angles that we would like to do. It would just be unbearable. Now, we know if we look at just A and B, just A and B, that there's a straight line, my green line, so A and B must be 180. right? We all agree they have to be supplementary and make a straight line. So then we could also create some angle that they haven't listed up here, angle E, and say, well, A and E also create a straight line, right? Like, if I put just A and E and just look at those, they also create a straight line. So what that really tells me then is if A and E equals 180 and A and B equals 180, B and E have to be equal. So these... Both, probably, but I'm going to wait is what I'm going to do. I don't know what's going on today, but I will outweight you all till the craziness of the room dissipates. It was a little okay for a little bit, and then I asked multiple times, we gotta get on topic finally, and it's just not happening, so I can wait you out. So on your paper, what you'd want to write is if A plus E equals 180 and A plus B equals 180, then it only makes sense that E is equal to B. This relationship is what we call, anyone ever heard of this before? Like Khan Academy or anywhere?
Probably.
Vertical angles. Vertical angles make sense to our brain. And stick with me on this ride of why. So if we have two lines that cross each other, not parallel lines, right? We know they cross each other at somehow. Now, here's the dangerous part though. Vertical angles make sense, but then again, our brains play tricks on us. If I grab this at relatively the center, most of you would be able to say, yeah, the left is equal to the right, the top is equal to the bottom. But if I grab this down here and I do this, a lot of you will say the top is bigger than the bottom. Well, first off, the bottom doesn't even look like it has an angle right now, but this is where people get goofed up. When the intersection isn't centered, this angle looks bigger because it has larger rays. It's got a larger space. But when we have two straight lines, right, and in math, if it looks straight, we assume it's straight. If we have two straight lines that cross, the opposite angles of the vertex will be vertical, which means they will be, fancy math word, congruent. Congruent, the symbol is equal with a squiggly line above it. So both. So why we use congruent is to not only talk about similar shapes, and that would be just the squiggly, but they're similar and equal at everything is equal. So when we get into shapes being congruent, it means a lot more than just angles being congruent, but the fancy word for equal is congruent. So vertical angles like B and E are congruent. So we can also go down to our bottom intersection here and say, okay, well, if I add on an F, we could say F is congruent to D, and if I add on a G, G would be congruent to C. Now, here's where things get interesting. If I were to cut that picture, the parallel lines, oh, yeah, I mean, it would be convenient, but we are where we are. Yeah, you could go ahead and make an angle H right here, the one missing vertex. You could go ahead and label that. Why did it copy at a different size? That's depressing. All right, so imagine with me that I was able to just nicely cut this. It's close. If I move this top parallel line down, Because it's appropriate. And to the left. Literally, this vertex that is up here and all of the angle relationships is the same as the vertex that's down here and all of its angle relationships. So this another vocab word is what we call corresponding. So corresponding angles. Yeah, well, today's the day of typos, apparently.
Corresponding.
There's a D there. Corresponding means same relative location. Meaning, if I look above and to the left of the vertex, like angle A, then I look above and to the left of the vertex, like angle C. So, angles A and angle C are corresponding to each other. But I should really probably have like an and in between there. Or, I could do like angle E and angle D, right? Top right, top right. So compared to the vertex, we're looking what is the location, right? So top right, if I look at E, I don't even know what color now. If I look at angle E, I'd be corresponding with angle D. Patrick?
Why aren't those lines just congruent?
What do you mean why aren't the lines congruent?
Why aren't the angles just congruent?
They are. So the other thing corresponding tells us is that those angles corresponding relationships create corresponding angles. So A is congruent to C. B is congruent to F. E is congruent to D. And G is congruent to H. Any corresponding sets will be congruent. Who's got questions on vertical or corresponding angles? Not what if the Starship Enterprise something. Simon?
So, if there are lines that are parallel, there can be more than two parallel lines, so they would have the same symbol?
So, if we created a set of parallel lines like this, and then created the transversal like this, then we would want to indicate that this line's parallel to this line's parallel to this line, and then this angle is equal to this angle is equal to this angle. And actually, we have symbols to represent that. Just like, and you might want to sketch this on your paper because the other one's probably getting a little messy, like that other sketch. And you don't have to sketch the whole, you could just sketch the top two lines. When we want to show congruent angles, we mark the angles. So to show this top right angle is congruent to this top right angle, we literally just mark it. But just like with parallel lines, if I'm trying to show that this red angle is congruent to this red angle, I can't use one tick. I already did that. So I can use two ticks, or another option would be to use two arcs. So like this would be another way that I could show a difference in angle, but I wouldn't use both of these. I would pick one, right? I either pick a double arc or pick a double tick. Either way, it's indicating that congruent relationship.
Can you have a triple one?
Yeah, you can have as many as you want.
Oh, sweet.
Now it starts to get messy, so that's when you choose other things. And then I could show that like green angle is congruent to blue angle, even though I made them different colors because they're different angles. I can show that they're congruent by giving that one tick, just like I had given blue. This is top right, this is bottom left. Now, to further that argument of are they the same angle or not, when we name angles, we name them using 3 points. Because if this point is B, what angle is angle B? Blue, red, or
Why did
green?
you make the other bottom one also blue?
Oh, that's
And they're different angles.
Because it's top right. They're all corresponding. Blue corresponds. Hey, Alina, don't ask a question and interrupt me. Thanks. Blue corresponds to blue, corresponds to blue. They're not the same angles, but they are all corresponding and they're all congruent. They're in the same location. Green's equal to blue, but they're in a different location. Green is not corresponding with blue. They're equal, they're congruent, but they're not corresponding. That's why I colored how I colored it. Does that make sense? Thank you. Yeah.
Is the red corresponding to the angle that you didn't mark? Right.
This, I just forgot the arrowhead on it.
Well, no, the other one. Like, the one
What, down here? Yeah, but I would pick a different color because they're not the same. So I'd go like purple 2 tick. So the 2 ticks tells me they're the same. Whatever I mark on the angles, because I don't expect that you guys are going to be working in colors a bunch, but this is just so our eyes can line up with like, oh, okay, I see what he's trying to do there. Now, let me get back to one thing before I take any more questions and we get deeper down the rabbit hole. When we talk about sets of lines, we often have labeled endpoints. So like I'll have a point C, I'll have a point D, I'll have a point E. This vertex is literally a point. So I can't say angle B. Unless I'm talking like, I've already used E. So if I do like X, Y, Z, K, L, M, like I can label the angles with letters, but if what we're working with is points, then now this angle is ABC. Because it starts at A, its vertex is B, and it ends at C. It could also be called CBA, because it could start at C, go to B, go to A.
But it cannot be
It cannot be called what?
a cap. CAB.
Yeah. Because if I start at C and I go to A and then I come to B, that's not the same. This is not that's not the angle I'm talking about. This is the angle we're talking about. Easy rule of thumb, the vertex is always the middle.
Or back.
Vertex is always the middle. Yeah, so no other arrangement of B not being in the middle will work. So like BAC will not work either.
Back.
Who's got a question about that? Because this is all new. I'm throwing a ton of new stuff at you guys. Well, like compared to what we've been doing. We've been doing a lot of work.
I don't know. I just remember this one.
Yeah, it depends on how much your teachers taught you. Probably not teaching what I'm supposed to teach, and we're probably talking about other things. Oh, if the lines aren't parallel, doesn't happen. So G and H are still supplementary, but there's no special relationship with E or F to G. Like, these aren't related because they aren't parallel. So E and F are supplementary, but F to G, no fun relationship there. F to H, no nice relationship there because they're not parallel lines. No, that we added those. So yeah, ignore these letters. Like these are two totally different situations.
Yeah, I know, but on that one, H, the angle above it, is that the same as B?
This
It's the one where it's unparalleled.
this
That angle.
H would be equal to this, but then up here this is different. Those would not be equal to H because they're not
I
parallel.
know, but are the green ones the same?
Yes, the green ones are still vertical. So thank you for that. Any intersection of straight lines creates vertical angles. So as Hazel was asking, there's no special relationships between green and blue, but like she said, green is equal to green because they are vertical to each other. And blue is equal to blue because they are vertical to each other. But blue to green has no relationship. We don't know.
So no matter the intersection, it'll always have
As long as they're straight lines. Yep. A lot of stuff I probably wasn't supposed to do. So, we get really quick math based off parallel lines then. If A is 107, and you can just kind of like work with me real quick because we got 5 minutes left, we're just going to work fast. What is B? Actually, hold on, we'll start easy. if A is 107, what is C? 107, because they're vertical. Then what is B? 73, because it is what they need to add to get to 180. Because 180 is your straight line. And then since these lines are parallel, what is... Oh, well, we could have... Stop judging. We could have actually looked down here and said, oh, well, if E is 73, B is 73. What's D? 107.
Which means C
Not
is
because they aren't parallel lines.
Take a moment on your own. Write down what H and F and K and M and R. Well, actually, M is a line. Sorry, don't care about M. Jumped out of the can.
Why am I looking at you every time you drop something?
Take a minute. I bet you can do this in 60 seconds. What I don't guarantee is that we cannot talk for 60 seconds. Let's try it. What is H? What is F? What is R? What is S? What is W? I don't even know.
It's just a stupid
9-2. So we should all just be kind of doing math with 180. 25 seconds left.
What if we're already done?
Good for you.
Can we do the funny ass stuff?
Ellie, what is F? Yeah, be careful that you don't forget to borrow. A lot of people will say 38 because they're thinking 50 plus 30, but it's 28 because we already have this extra 2.
And you can also just flip
And then, Josh, what's H? Yeah, also 28 because they're vertical, right? And degrees, of course, guys. We want to be labeling these degrees. Katie Ann, what is R over here? Yeah, 130, and that's fine. You don't even have to have done it already, right? Your brain just has to be able to subtract from 180. So R is 139. Oh, you don't even have to subtract because they gave you the other one. And did you see that? The ghost just yanked that chair out.
Oh yeah, the ghost.
Yeah, go watch the video. You'll see the ghost.
The ghost of Phoenix is here.
Okay, the last thing I need you to know, and I gotta get you out of here then, is alternate interior angle. Guys, you might want to write this down because this is clutch to use that word a lot of you didn't know. Alternate interior angles are literally on the alternate sides, both on the inside of the pair, right, of the parallel lines. But imagine when we cut that picture and we slid it up. If I cut this picture and I slide it up, why? Hazel, can you guess the relationship they have? Yeah, because why? Yes. There probably is. It's like a parallel set with a transversal, but there's probably a fancy name for that. So, alternate interior angles are also congruent. So, like X is congruent to Y. 1 is congruent to 2. Yeah.
This is just totally
That's just broke math.
That's super useful when you're trying to solve these problems. All right, we'll pick up here tomorrow.